Let's look at OpenStax College Physics, Chapter 12, Problem 6. A major artery with a cross-sectional area of 1 square centimeter branches into 18 smaller arteries, each with an average cross-sectional area of 0.4 centimeters squared. By what factor is the average velocity of the blood reduced when it passes into these branches? So let's write down the things that we know and whatever we're looking for. So we know that the cross-sectional area of the artery is 1 square centimeter. And then that artery branches out into 18 smaller arteries of cross-sectional area of 0.4 square centimeters. And there are 18 of that. What we're looking for is what factor the average velocity of the blood reduces. So we're looking for V2 over V1. All right, so here I drew a squid-like thing. This is actually the artery, the major artery, and it branches out into 18 smaller arteries. And we know that the volume flow rate, the volume of blood that we had in here that was moving through the artery has to be kept constant. The blood is not going anywhere, and the speed that it comes in with will have to be distributed somehow in these smaller arteries. So then we can say that the area, the cross-sectional area of the major artery times the velocity of blood in that artery is equal to n times A2, A2 being just the cross-sectional area of one of these little vessels here. So those were A2, but then there's n of them, times V2. So here this was cross-sectional area A1, here was velocity V1, and then the velocity through here is going to be V2 through each one of those smaller arteries. So we're looking for V2 divided by V1, so that will be A1 divided by NA2, and I'm not going to convert from centimeter squared to meter squared because both top and bottom here have the same units in them, so they're going to cancel out. So I'll just leave this as 1 centimeter squared divided by 18 times 0.400 centimeters squared. And if we divide these two numbers, we end up with 13.89%. So the speed reduces by 13.89% as it's going from the major artery into the smaller arteries, and that's because there are more, the total cross-sectional area of the smaller arteries is actually larger than the cross-sectional area of one of these, than the cross-sectional area of this large artery.